So we've talked a little bit about water movement in soil, a little bit about air movement in soil, but now let's get more into the discussion of how other liquids move in soil, and let's particularly look at non-aqueous phase liquids. And so we're going to call those NAPLS. Okay, and here is a bottle of NAPL I happen to have with me, and you'll notice that it has a very different viscosity than water does, has a different density than water does. There's a lot of things about that fluid which are going to be new features compared to how water moved in soil. Now, one of the things with NAPLs is they're generally complex mixtures. So why do we care that our NAPLs are complex mixtures of different compounds? That's because each of these elements is going to have its own volatility. Okay. So, and it'll have its own other properties as well, for instance, the viscosity. So if we have a gasoline, which is made up of a vast number of compounds, what we're going to have is a volume of this liquid, let's say NAPL, and then let's divide it into different subvolumes. Okay, so we may have benzene, we may have octane, etc. Okay? And what's going to happen then as this NAPL ages? What happens is different compounds are more volatile than others. And so this compound, this mixture of compounds is going to age. Okay, so now we have this oil in a soil, let's say. It's been a contaminant spill. And in time, the most volatile fractions come off, leaving the less volatile, generally higher viscosity, generally less biodegradable fractions. So when we start talking about non-aqueous phase liquids, we have to think about them in terms of not only what are the properties of the original compound, but also what is the influence of aging on this situation. As you can imagine, the aging is a function of the rainfall, the temperature, the depth of the spill, the biological activity at that site. So this aging is very complex. And from that point of view, we want to emphasize that we cannot accurately predict many of the true properties of NAPLs in the environment. So our accuracy of making predictions of NAPL movement are fundamentally less precise than that of water. So volatility is certainly an issue when we talk about non-aqueous phase liquids. Another key issue is surface tension. So if we have a water surface, and if the surface tension of our NAPL is high, and we'll use the symbol sigma for surface tension, then the NAPL will stay in a blob, and we'll call that a non-spreading. Now, if any of you have taken a bath with bath oil, you'll remember that you put the bath oil in, it's in little blobs, and then you kind of relax, everything goes fine, and where's my oil? It all spread out. And that's because what happens is the oil will contaminate this surface. So this surface is going to have a decreasing surface tension as well. And this surface tension will get contaminated with water, and what we end up with then is a completely spreading NAPL. And any of you who have seen like a puddle of water where someone dropped a drop of motor oil, you'll see the sheen of a spreading oil. The challenging thing about this whole thing is all of this is time dependent. And so, it's time dependent. And so what happens is you start by putting oil in. Many oils will start as non-spreading oils. Then as they age, as the volatility and the contaminate, they start to, at a molecular level, spread and contaminate each other. Then the interfacial tension between the two becomes more similar, and it becomes a spreading oil. You can imagine how different the prediction is. If I pour some olive oil on the ground and it's a non-spreading oil, I'd have a very small volume of contaminated soil. Whereas if I put in a spreading oil, it goes over all the water surfaces and can go for many, many meters. So this issue of surface tension of the NAPL and that it is time dependent really presents a tremendous challenge for prediction of the movement of non-aqueous phase liquids. Once again, this is a much more complicated problem than what we ran into with just describing the movement of water in soil.